When you open a website, you type a name, not an IP address. But servers don't understand names. They understand numbers. So who translates between the two? That's DNS. DNS stands for Domain Name System. It is a distributed and hierarchical naming system. Its job is simple: translate domain names into IP addresses. For example, google.com maps to 142.250. something. Let's see how DNS works behind the scenes. Step by step. First, your application or browser sends a request to a recursive resolver. This resolver is usually provided by your internet service provider or a public DNS service, like Google DNS. If the resolver already knows the answer, it responds immediately. If not, it begins querying the DNS hierarchy on your behalf. Here is the complete DNS lookup flow. Step 1. The browser checks its local cache. Step 2. If no record is found, the browser queries a recursive resolver. Step 3. The resolver contacts the root DNS server. The root responds with the location of the TLD server. Step 4. The resolver queries the top-level domain, or TLD server, such as .com. Step 5. The resolver queries the authoritative DNS server. This server holds the final and trusted answer. Step 6. The IP address is returned to the browser and cached to improve future performance. DNS is not just about IP addresses. It uses different record types. These record types are defined by DNS standards and stored on authoritative DNS servers. An A record connects a domain to an IPv4 address. An quadruple A record connects a domain to an IPv6 address. A CNAME record points one domain to another domain. An MX record controls where emails are delivered. A TXT record stores extra information, often used for verification and security. DNS performance is critical. Every millisecond matters. That's why caching exists. When a DNS record is resolved, it is stored temporarily. This avoids repeated lookups and reduces latency. The duration of this cache is controlled by TTL, time to live. A lower TTL means fresher data. A higher TTL means better performance. DNS security is just as important. That's where DNSSEC, or Domain Name System Security Extensions, comes into play. DNSSEC protects against DNS spoofing and cache poisoning by using cryptographic signatures to verify that DNS responses are authentic and untampered. If DNS fails, your application fails. Servers may be running, networks may be fine, but without DNS, nothing is reachable. DNS is not magic. It is infrastructure. It is distributed, cached, hierarchical, and critical for scalability. No DNS, no internet. If this helped you understand DNS deeply, like the video, subscribe, and stay tuned for more Tech Explained Simply.